Measures of center, sections 2.3 to 2.4. The mode, median, mid-range, and mean are known as measures of center or central tendency or location. Again, consider these 12 exam scores ranked from smallest to largest. Smallest score 28, rank 1. Next smallest 59, that's rank 2. And then 65, rank 3, and so forth. We want to find the mode. Mode is most frequently occurring exam score. There can be more than one mode. If each data value occurs only once, then there is no mode. So the most frequently occurring exam score is the 88. That occurs twice, so that would be the mode here. The score of 88 is the mode. So the answer is 88. That's the most frequently occurring score. Number 2, find the median. The median is the middle number or the average of the two middle numbers. It's the same as the 50th percentile or the second quartile. Now we have an even number of exam scores here, so there's going to be two numbers in the middle. Average of the two numbers in the middle would be 82 and 83. I'll use those for the median. So it's going to be 82 plus 83 divided by 2. 165 divided by 2 comes out to be 82.5. That's the median. The mid-range is the average of the smallest and largest numbers. So it'd be 28 is the smallest, largest is 92. 28 plus 92 is 120 over 2, which would be 60. Okay. The mode and the mid-range are not used so much because one exam score can have a big effect on the mode and the mid-range. The median is the median and the mean are the most common measures of spread. Okay, so let's do the mean. And mean is computed by adding up all the scores divided by the number of scores. Sometimes it's useful to write a formula for the mean. So for that we use the Greek letter capital sigma, meaning sum. And the summation here will say at the bottom says k equals 1, and the top it says n. So that means as k goes from 1 to n. Sometimes I is used for index of summation. You'll say I equals 1 to n, so it's the same thing. Okay, so x1 would be the first exam score, x2 the second exam score, and so forth. So if we have, and the symbol for the mean is x with a bar on top. It's x bar equals, summation is k goes from 1 to n of xk over n. In this case we have 12 exam scores, so n is 12. So it's going to be the summation as k goes from 1 to 12, xk over m over 12. And then, so that means, so what does sum mean? It means the first exam plus the second exam plus the third exam and so forth up to the 12th exam. You want to add up all those scores, divide by 12. So it's 28 plus 59 plus 65, etc. That comes out to be 923. And then divide by 12. 12 into 923. It goes 12 doesn't go into 9, it goes into 92 7 times. 7 times 2 is 14. Carry the 1. 7 times 1 is 7 and 1 is 8. Remainder 8. Bring down the 3. This will be a 6. 6 times 12 is 72. Remainder 11. Bring down a 0. This will go 9 times, I think. 9 times 2 is 18. Carry the 1. 9 times 1 is 9 and 1 is 10. Remainder 2. Bring down the 0. 12 into 20 goes 1 time. Remainder 8. Bring down the 0. This will go 6 times. And we're going to get repeating 6s. So it's going to be 6 with a bar, dot, 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 or approximately 77. Okay, so okay, just a comment about the effect of outliers. The outlier of 28 was quite a bit less than the other scores and brought down the mean. The mean is affected by outliers, whereas the median is not. Because the median is not affected by outliers, it is known as a resistant statistic. The fact that the mean is less than the median indicates the data is skewed left. Nevertheless, the mean is an important measure of spread because measure of center rather, because there's a very strong relationship between the mean of a sample and the mean of a population. Okay, so next, another measure of center is the weighted mean. Sometimes we don't want to weight the scores equally. For example, if you're taking a course, oftentimes the final exam is worth more than the other exams, is given more weight. Also, later in the course we're going to be we have a unit on probability, and sometimes we'll be weighting scores according to their probability to compute a weighted mean. Okay, so for this example, we want to find the weighted mean if the first 11 exams are each weighted 5% or 0.05, and the final exam is weighted 45% or 0.45. For the weighted mean, we want to use the original order. And assuming the weights add up to 1, the formula for the weighted mean, there's the sigma notation again. Summation as k goes from 1 to n, xk, wk. And again, sigma means, as the Greek letter capital sigma means sum or total. Xk represents an exam, wk would be its weight. It's going to be convenient to make a little table to do these, so we make sure we do the right order of operations. So according to this formula, multiplication comes before addition. That's the order of operations. So we want to multiply, the first operation we want to do is multiply each exam score times its weight. So that's what the formula tells us. So when we set up this table here, we can set up a column for the exam scores, column for the weights, and a column for the product, because that's the first computation we want to do. Each score times its weight. So the first exam is 80. Its weight is 0.05. 80 times 0.05 is 4. Second exam, 88. Its weight is also 0.05. 88 times 0.05 is 4.4, and so forth. Last two I didn't fill in yet. I'll fill those in now. So the 11th exam, the score is 89, and its weight is 0.05. And we want to multiply 89 times 0.05. 9 times 5 is 45, carry the 4. 8 times 5 is 40, 44. It's going to be 4.45. And then the 12th exam, that's the final exam, that's weighted more. It's going to be 82 times 0.45. So it's 82 times 0.45. 2 times 5 is 10, carry the 1. 8 times 5 is 40, and 1 is 41. 2 times 4 is 8. 8 times 4 is 32. And we add these up. I get 36.90. Okay, and then the weighted mean is just going to be the sum of this last column. The column total here is 78.95. And one thing to notice here is that the final exam was, the original mean was about 77, so the final exam score was more than that, and that actually, so it makes sense that it would raise the mean then. The student's grade came up on the final. So the weighted mean is almost 79 here, and the original unweighted mean was 77. So the final exam being weighted more helped the student here. Okay, the last thing I want to do is a proof. We're not going to do a lot with proofs here. we'll do a little bit with proofs. If you take a course in mathematical statistics, you'll see a lot more proofs. This theorem I want to prove is that if the exam scores are weighted equally, then the weighted mean is the same as the regular mean. So algebraically, that means the summation as I goes from 1 to n of xi wi is the same as the summation as I goes from 1 to n of xi all over n. So to prove this, what I want to do is start with the left side of the equation and manipulate it to try to get it equal to the right side. So we're starting with the left side here, the summation I equal 1 to n xi wi, and because the scores are weighted equally, we said if the scores are weighted equally up here, then each weight has to be 1 over n. So I'm replacing wi with 1 over n. So if you split a pizza among 3 people, then each person gets 1/3 of a pizza, or 1 over 3. If you split a pizza among 17 people, then the fraction that each person gets is 1 over 17. And if you divide a pizza among n people, then the fraction each person gets is 1 over n. So it's the same idea here. We're weighting each exam score equally, so each weight has to be 1 over n. And then we use the definition of sigma. That means the first exam times its weight, plus the second exam times its weight, plus etc., plus the last exam times its weight. And then we can we have a common factor of 1 over n, so we can use the distributive property to in reverse to factor that outside of parentheses. And then inside parentheses we have x1 plus x2 plus etc. plus xn. And that, now we can go back to sigma notation. That's this x1 plus x2 plus etc. plus xn. It can be written as the summation as I goes 1 to n of xi. And I copied the 1 over n. Okay, so then we can make this into a fraction by putting over 1. Use the rule for multiplying fractions, multiply straight across, and that gives us the right-hand side of the equal sign, what we were trying to prove. So the summation as I goes from 1 to n, xi all over n. So that's just by the rules for multiplying fractions. It looks like I'm frozen here. Am I frozen? Okay, no, I'm not frozen. Okay, so that concludes this presentation.